Perfect. So as you may have heard, recording is on now. And let's get this started. Okie dokie. I will now share my screen. All right, do you see my screen?
Yeah, we do.
Perfect. So thanks for being here. Let's present. So basically, I spent the time between Christmas and New Year's going into Airflow 2.0, and since I think quite a few of you are working with Airflow in some way or another, I thought it might be interesting for you guys to learn what it's all about. So I threw together a little presentation. I'm happy to share this as well as the recording afterwards, and just let you know what I found, what's new, and yeah, this is what today's about. I'll start with a very short introduction about myself. As I said, most of you probably already know me, but it might make sense to also just give you an overview how Airflow affects me in my everyday life, how I use it in everyday work, and that also should give you an overview about how I approached Airflow and from what angle I looked at it. So that's going to be the first two parts, just short about and short philosophy. Then the big part, what's new. I will start that with a short recap of what Airflow actually is. I assume that everybody here knows Airflow and has worked with it before, but I just want to just give a real quick recap so we're all on the same page. And then I'm going to basically summarize the changes and then deep dive into the three biggest changes in my point of view. And then at the end, I will also show you a custom package that I use with Airflow. It's an open source package that I'm developing called Eva. Just going to give you a quick overview. I'm also going to use code from this repository as examples. So throughout these two parts of the session, I will be switching between the presentation and code. So I hope that this style is going to be good for you guys. It's my first presentation like that, so we'll figure it out. With that in mind, please always shoot questions. So don't hesitate if something's unclear or if you want to talk about something in particular that I'm talking about in the moment, or you want to dive deeper. Please feel free to ask straight away. Because I'm not really looking at the messages in the meeting, just basically unmute your microphone and let me know. That's absolutely fine. Of course, unless you do want to ask a question, it's great to be muted, but as far as I can see, everybody's doing that already, so awesome. And finally, I want to have a Q&A, and this is anything that relates to Airflow, really. This is more, I think, more of a discussion between us as Airflow practitioners, rather than like a one-to-many conversation. I think we can, if you have topics on Airflow that you want to discuss, maybe you have a question that some of us might be able to answer, even if I might not be able to answer it, somebody else might be able to. Or if you have questions on the Eva library, same thing. Happy to answer any questions there. Or if you have any other topic on data engineering, I think this is a nice round, so we can do that here. And the last slide is a contact slide. I don't need to show that to you, but it will be part of the PDF that I will send around. So if you ever want to contact me, you have my Slack, you also have my email in the Slack, and then you also have my telephone number. So yay. Cool stuff. So this is what I want to do today. So let's start with about me, about us. So I'm the founder of Gemma Analytics. Before that, I was a freelancer in the BI space. Before that, I was head of BI at two different companies. So I basically built up BI infrastructure from scratch twice. Then as a freelancer, I built up data infrastructure with them. One of my earliest clients is right here right now as well with David. technically David wasn't in with the client, but the client itself at the time. But the client was, I think, my #1 client of my freelance times, and still working with them. I implemented Airflow with them as well. So you might be interested also to understand what I actually did in the last couple of days with their implementation. And out of that I founded Gem Analytics with my co-founder Lennart. At this point, we have quite a few clients. We have quite a few colleagues. Currently we're 4 people, 3 are signed, and we are growing. And I'm essentially responsible for anything that really relates to tech and data engineering and that kind of stuff. And as you see, some buzzwords. We work in ELT paradigm. We work with open source, both as tools that we use and also producing an open source tool ourselves. We work with Airflow a lot. We work with dbt a lot. I absolutely love dbt. So the only thing that I use more than Airflow is dbt. And of course the classics, BigQuery, Snowflake. That's just some buzzwords for you guys. But that's enough about me. This is a sort of standard slide that we often show in terms of how the BI stacks look that we work, and that might inform you how we use Airflow. So you can see Airflow is here on the top left corner. We always use an ELT framework. I don't think I need to convince you guys why, so I'm not going to go into too much detail. But yeah, basically, BigQuery, Snowflake, or Postgres is data warehouse, dbt for transformation, whatever visualization tool for visualization, and if data loading, either using Stitch, Fivetran, some software as a service. If that is not possible or desired, then we implement Airflow. And that's why we're here. And this Airflow implementation, that is my job. So I have implemented Airflow with every client that we implemented Airflow. So I've built quite a lot of setups at this point. Yeah, this is good and bad. It's good because I've obviously also seen a lot of setups and had a lot of challenges, but it's bad, of course, because I probably keep doing the same things with Airflow. So it's easy to get lost in your own logic without seeing other stuff. Yeah, this is basically how I approach it. So we use Airflow essentially for data loading from data sources to the warehouse without any transformation, essentially.
Just one question, if you don't mind. What do you use for data quality in this framework you have? So is there any tool or any?
So we like to use the data tests that are part of the dbt framework. And that's probably the most extensive data quality testing that we do. So when we write our dbt models, we also write tests for those models. And these tests are more basically black and white tests. So making sure that you don't have duplicate primary keys, making sure that you have, like, the data that you have are fall into expected ranges, that kind of stuff. But it's black and white in the sense of these are tests that should never fail, and if they fail, there's probably something really wrong. One thing that I want to get into in the next couple of weeks is trying out Great Expectations. I think it's one tool that is getting quite a bit momentum right now, where you can also have more of a grayscale approach to data quality and data testing. I think that's quite promising. But those are the two things that I would say we use for data quality.
We added Great Expectations now in Zalando for my last client as a part of Airflow, and it's pretty good. So I would recommend that. Yeah.
That's good to know. I've heard it from a couple of people now, so I'm really looking forward to, when I have the time, getting into that. And there's actually already an Airflow operator for Great Expectations, if I saw it correctly.
It's not going to do the job, so you better wrap it up. But I think they fixed it up a bit now with the recent release, but I'm not too sure.
Yeah, it has also been my experience that the community provided operators are nice to get a start, but usually I did end up writing my own operators for many things.
Thanks for the question. I'll check dbt. So.
Alrighty. So this is the stack that we usually have, and I think David is going to find himself here, and there's another client, Lucas, also, who will also probably remember the slide, in fact, from a pitch deck at some point. But now let's get into the topic. Airflow 2.0. What's new? As I said, I want to give you a short overview about the most important concepts in Airflow. It should not be new to most of you guys, but maybe it's a nice refresher. And then I'm going to go into what's new. And from the what's new list, there's 3 things that I'd like to go into a bit more detail, just because I think those are the most interesting things. But if there's other things you want to go into more detail, or if it's either too high or too low in terms of detail, just shoot, let me know. Happy to go deeper. As I said, I played with Airflow 2.0 during the winter break, and I have at this point deployed it with 2 clients. So we do have it running in production. Having said that, it is still quite buggy. So I think the Airflow team themselves say that the first stable release really is going to be 2.0.1. But I expect that to happen in the next, I think in a week or so, it's going to be the release. Anyway, let's get started. So, revision on Airflow, how Airflow works. I just stole a pretty easy picture from the internet here. So of course you have a metadata database, and then you have your DAGs folder, which are Python code where you define your DAGs, and then you have essentially for the web server, the scheduler, and the workers. The minimum processes to run Airflow are the web server and the scheduler. So the web server reads the metadata database, gives you an up-to-date overview where Airflow currently is. So this is the user interface, so to speak. You can also use it to run commands like execute a DAG. You can use it to view logs, right? All this kind of stuff. But it doesn't, other than turning DAGs on or off, or adjusting connection details, that kind of stuff, it doesn't really do anything relating to the scheduling or execution of tasks. That's where the scheduler comes in. And the scheduler is the second essential process. So essentially to run Airflow, you need to have these 2 processes. Technically, probably scheduler is going to be enough, but you are going to want to have some UI to have an interface, of course. So I would say the 2 processes are what you want to have as a minimum. The scheduler basically runs through your DAGs folder, reads executes the PY files, looks into the namespace, and checks if there are any DAGs objects in that namespace, and if so, it will import them, and then schedule them. So basically, every 30 or so seconds, checks what time is it. Is it time to run another DAG, and then runs them. And then it depends on what executor you use, how they are going to be run, because the logic differs quite a bit between what executor you used. I purposefully used this very simple image. And there are, I think, 7 or 8 executors at this point, but I'd say the most important ones are these 4, where the sequential executor is probably only relevant for local development, even though I even don't use that for local development. I use the local executor, but you could use that, where the sequential executor, just executes 1 task at a time and nothing more than that. The local executor, that's basically where you really only have the web server and scheduler processes, and the scheduler process itself basically forks child processes that on the same worker that execute the tasks, and when they are done, it basically reports back to itself the task status. So there's still only 2 processes. And then the Celery and Kubernetes executors are a bit more scalable, a bit more performant for larger Airflow implementations, where there you actually have separate processes potentially on separate worker machines that execute their tasks. In the Celery executor case, you're going to have a queue like usually RabbitMQ, where the scheduler sends tasks to the queue, and then the workers, which are separate machines, take the tasks from the queue and execute them. And the Kubernetes executor is where the scheduler spawns the workers. The workers are new pods, run execute the task, and then spin down again when they're done. So as you see, the logic, how Airflow really works in terms of scheduling depends on the executor. But this is a DevOps topic and doesn't really matter for us in this talk. And having said that, maybe FYI, I've never really used the Celery executor in production. So usually I either use this local executor if the task load is not too high, fairly easy to maintain, to use, or I use the Kubernetes executor straight up. And I never really dealt with the headache of setting up a queue and all the other stuff that you need for the Celery executor. Probably not too complicated. I know some people here, for example, Adrian, I think you always use the Celery executor. And this used to be the most popular one. I believe it maybe still is, but yeah, I can also recommend using the Kubernetes executor. I mean, if you're at that point, you can just go straight to K8. So that's the first part. And then the revision, how does it work? I'd really like to just talk about 3 concepts here, about DAGs, tasks, and operators. So I'll just quickly go through the DAGs. As you probably all know, DAGs are really directed acyclic graphs. So graphs from graph theory are objects that have 2 things, edges and nodes. Our edges are dependencies, and our nodes are tasks. And it's directed and acyclic, so that means the dependencies have a direction. So A might depend on B. It's acyclic, that means you can't have a circular dependency, and it's a graph, as I said. So that's really all that is. And then DAGs can have DAG runs, and each DAG run is one execution of the DAG. They can be scheduled or manual, like you can manually trigger a DAG. And these DAG runs have a context, and I think the most important context is the execution date. Not going to go into too much detail, but for example, when you have a DAG that runs daily, you have one DAG object, which is defined by your code, and then every day you have a separate DAG run object, which is the actual run on that day. Then you have the tasks. The tasks, as I said, those are the nodes of the DAGs. Tasks are instances of the operators, which is the next concept. And these are basically defined in your Python files as well. It says what operator are you going to use and what arguments are going to be passed. And the DAG run essentially instantiates the operator. So the operator is a class, and the task is essentially an instance of the class that then runs during the DAG run with the context. And then the operators themselves, this is essentially where the magic happens. This is where the actual code is defined that you want to run. Everything else that Airflow offers, like hooks, connections, etc., those are features you can use in the operators. But this is this is basically helper for your operators. You can use operators without anything else, without hooks, without connections, but you cannot use Airflow without operators. And these operators are going to have 2 methods, the init method and the execute method. And the Airflow, of course, ships with a number of standard operators, but you can also build your own operators. And I know this is just me, reading my slides right now. So at this point, I'd like to just jump into code and give you a couple of examples of how this might look like, unless you have a specific question already. Any questions? Okey-doke. So these are 2 example DAG definitions. And the first one, so this top one, is basically just a DAG with one task, with a Python operator task. So the Python operator is a default Airflow operator that ships with Airflow, right? It has a couple of arguments. These are then given to the init function of the operator. And you define high-level details of the DAG itself. What's the name? How often is it going to run? And then you're going to define the KWalks of the tasks themselves. What happens then when Airflow runs is Airflow runs through the DAGs folder, reads the PI files, sees are there any DAGs in the namespace, imports them. So this is one example what it might look like. Here's another one, same thing, different operator. This guy is the bash operator. And yeah, this is probably quite familiar to all of you, or most of you at least anyway. And you see in the top one, I used the context, and here I didn't. So you can just either define what DAG a task belongs to, or you can just use the execute context, the Python context here, and it will automatically know the correct DAG. And if we look at how this then might look in practice, this is the new Airflow 2.0 UI. This is the RBAC based UI. I'll come back to that in a second as well. And then you might have this operator. This is in case just one node that runs here. And if you have more than one task, then you can have different tasks. And then you can see here the dependencies between the tasks. So this runs first, then the other stuff runs. And this is the basics. And then maybe one step deeper would be if you build your own operators, what might that look like? So maybe it's easier to just show you in a standard Airflow example. For example, this is the Postgres operator that Airflow ships. Airflow has a base operator, and every operator has to be a child class of that base operator. That's basically where Airflow does all the logic and the dependency matching and adding the task to the DAG correctly and all that kind of stuff. And then the child class really only needs two functions. As I said, it's the init function and the execute function. And when the init function runs, then basically one thing it always has to do is call the super with the extra arguments like task ID, what's the DAG, etc. And then usually all you do in an init function is just save the arguments. So and make them so that they are available upon execution. And then when Airflow runs, it runs the execution, the execute method, and then basically does whatever is defined here. And in this case, it uses the hook to connect to a database, run a query, return the result. Yeah, so this is how Airflow works. I hope I didn't bore you guys too much, but I thought just to get everybody on the same page, I might add that here anyway. So anybody have any questions? Nope. All right. So let's get into the interesting stuff. What's new? So in my point of view, these are most of the new things. I also wrote a link here where all of them are mentioned as well. I just want to go through this one by one. And then, as already said, I want to go into the details in the three most exciting ones. And I'll let you know what that is in a second. So let's start here, the TaskFlow API. So this is essentially a new way of writing DAGs. To me, I think that's just a very nice syntactic sugar. If you're interested in that, I recommend just going to the blog post and taking a look. It looks very straightforward. It uses decorators to make essentially using the Python operator easier. And it also automates using XCOM, so the moving data from one task to another, which personally is something I don't like to use. So the TaskFlow API for some people might be very nice. For me personally, I'm probably never going to use it. But the use case is essentially to make it easier to write DAGs and make the DAGs that you do write better to read, like more readable. There's a good example in the link, so I recommend you check that out. The next thing, and that's very interesting, is smart sensors. So if you run a lot of sensors, then this is going to be for you. For those of you who haven't worked with sensors so much anymore, it's essentially a type of executor that, a type of operator that senses something in the sense of that it runs and then it checks for a condition. And if this condition is fulfilled, it will be successful. And if it's not fulfilled, it will just go to sleep. And then after a set period of time, check again. This can be very useful for many different reasons. For example, if you have interdependencies between DAGs, or if you have interdependencies based on external systems, you need something else to be the case, some other external process to have run first, some data to be available, some file in an S3 bucket. You want to have a sensor to check for it, and the rest of the DAG is only going to run once this is successful. And smart sensors is very good for people who have a lot of sensors. Because whenever you run the sensor, it has to spin up the worker, it has to run the it has to run the execute method of the operator. The execute method has to use the poke function that actually checks, and it has to do all these things, and this can be a lot of overhead for very little gain. If you want to poke every 5 minutes, but it might take 5 days for something to be the case, and you have 100 of these, that was not very efficient in the old way of doing it. Smart sensors solve this for you. It's a very nice feature. For me personally, I tried using it. It turned out not to be a good use case for me, and I'll also tell you why that is. But I think for a lot of people, it may be very, very useful. Then the next thing is providers. So Airflow used to ship with different packages as well. So if you install Airflow via pip, you have the Airflow core, and you can say, okay, I just want to install the complete package, Airflow all, like with the brackets. Or you can say, no, I just want to install everything that relates to GCP or AWS or Postgres, or so you don't have to have the full installation, because there you had a lot of dependencies, but it wasn't perfect, to say the least. And they solved this now by so-called provider packages. So now you have one core Airflow installation, and that is very lean, and everything else is moved into separate packages, so-called provider packages. And there are two types of provider packages. There are community contributed provider packages, and you can also code your own. And I'm going to give you examples of both, because I think this is a super neat feature, and this is probably the number one thing that I really like about the new Airflow, besides insane performance improvements and that kind of stuff. But this is very useful. That was a very good idea and also well implemented in my view. But I'll get into the details at the time. Then there's custom connections. So the custom Airflow connections are essentially a sub feature of the providers, because you need to build your own provider to create a custom connection. But it's worth it if you have the use case, because you can change the connection form. So previously, you might know that the connection form, when you add a connection in the UI, it's always the same. Ask for a host, ask for a schema, ask for login, password, extra, and port. But not all connections have this exact list of attributes. Some just have an API token. Others have even more things that you need to supply. And maybe you need to supply a database, but not a schema when you connect to something. So this was like it. Probably many people like myself just hacked it. So if I had a MySQL connection, I know I would put the database name in the schema. So it says schema in the UI, but I know it's a database. But that's not exactly perfect. And with the custom connections, you can change that. You can change the labels, which is nice. But what's even nicer is you can also add different widgets. And you can also add different widgets of different types. So just not just the form widget, you can add number widgets, or you can add password widgets, or you can, that kind of stuff. So I think that's really cool. This custom connections, I'm also going to give you, show you how that works, because I've already implemented this in the Eva library that I've turned into a provider. So yeah, I think this is super cool. Then the Scalyr is just so much better. I think Astronomer did a benchmarking test, and it's something like 20 times faster. Aside from that, you can also have multiple scheduler processes in parallel now, which previously you couldn't. So you can have a high availability implementation where you have like 3 schedulers run. I see somebody's happy now. And so you can have it in different zones, and you can have failovers and that kind of stuff. And also, if you have multiple schedulers, it also improves the speed. So there's also not just a failover and high availability feature, but also a performance feature. And then there's a couple of more things. There's a full specified REST API now, which I think is neat, especially for Gem Analytics use case, because we will start using this to ping the status of our client implementations, and we can have a central dashboard of all our implementations. Always see for all our clients in one place, is their Airflow alive? So that's, I think, pretty cool. But you can also use this to run DAGs, execute DAGs, add DAGs, delete them. Everything you do in the UI, you can also do with this REST API. The Kubernetes executor has been simplified. I want to tell you straight away, this is the one topic I didn't look into yet. This is on my to-do list, so I can't exactly tell you what has changed. I have some. I know some things that have changed, but it's like dangerous half knowledge. So I'm not going to expand on it before I'm gonna, before I bullshit. Just so you know. But it is simplified and it works differently now. And finally, there's task groups. This is essentially a way to group tasks in the UI to make it, to make big DAGs easier to read. And this is meant as an alternative to the subDAG operator. So that instead of having, so you know that you can have a DAG as a task in another DAG. Apparently, the Airflow community didn't really like it. So they basically introduced the task grouping feature. So you don't do the subDAG hacking anymore, but instead can have this feature of grouping tasks together into one task and being able to drill down into this task while still just using tasks instead of task groups. Yeah, there's a couple of things, like the UI is refreshed, as I said. You can only use the RBAC UI, so the old UI is now deprecated. You can't use that anymore. Yeah, some details, as I said, are more, but I think this captures the important changes, this slide. Do you guys have any questions at this point? That's a no. Then let's get into the details after having a bit of water. All right, so smart sensors. As I have previously said, that smart sensors are very nice for those of you who love sensors. So I stole this this image from this link. So if you want to go deeper, feel free to take a look at that. Basically, the way this works is that when you have a sensor that is a smart sensor, you still have the sensing task, but instead of executing the operator, Airflow will notice, oh, this is a smart sensor, and then it will register the sensor instead of executing it. So if you, for example, use the Kubernetes executor, it will not spin up a separate pod. It will just see, oh no, this is a smart sensor. I am not executing this by myself. Instead, it just records, okay, this is what I want to do. And it will then put it into the metadata database. And then there's a separate DAG, and this is a system DAG. So not something that's in your DAGs folder, but it's something that you activate with your config file. And in these DAGs have just one task, and this one task is just continuously running. It's a bit hacky if you ask me, but it gets the job done. And this continually running task is just an infinite loop, which checks, did you register a new a new thing to task, a new thing to sense? And then it senses that. And the way it does is, it gets the registration essentially needs an information, and you do that in the smart sensor operator class. When basically when your task is instantiated and your init runs, you save the keyword arguments, and then you have an instance of your operator class, which is the task. And instead of running the execute method, it will just save the arguments that you gave. So it will check for the attributes on your operator, save them in the metadata database, and you have to give it the list of attributes that it wants to save, and it tells them the class. Then the executor, when it runs here, it will reinstantiate the class, give the arguments to this class, but instead of using the execute method, which was the case before, it will use the poke method. So those people who are familiar with sensors, the execute method of sensors usually calls another function, which is the poke method, and this poke method returns a Boolean, true or false. And basically, thereby, each poke is basically one check. Is the file in S3? And if the file is in S3, then it will return true. And the execute method will say, oh, I'm done. And if it returns false, the execute method will wait for 5 minutes and then poke again. With the smart sensor, it completely ignores the execute method. It goes straight to the poke method. That's I think very important. Also the reason why I couldn't use it, but I still think it makes sense the way they implemented it. And basically, this one operator, the smart sensor operator, just takes all these classes, pokes, and if it's successful, it will return this information, and then it will set the original task to successful. Basically, the original sensor task gets set to successful by the smart sensor task. And as I said, this is a bit complicated, but it is very good if you have a lot of simple sensors, which don't have complicated custom logic, but which run many times, because you really only have one task that executes all the sensing. And that is like, the more sensors you have, the more you're going to love this feature. Like if you only have 5 sensors, you don't need it, too much overhead. If you have 500, this is absolutely awesome. Okie doke. I might spend some time looking at the code that is used here, if you would like that. But having said that, this feature is the one feature I know the least about, because as I said, that's the one I didn't actually implement, but I still think it's quite useful. So please let me know if I'm wasting your time here. But anyway, so what you need to do, actually, I might open this link. Might be the easiest thing to do. So as you say, this is a picture of how it used to be. This is the one that I stole. And I mean, I'm reading from the docs here from you, but really what you need to do to activate the sensor is have this configuration in your Airflow config or environment variables, set the use of them to true. There's a sharding, which means Airflow will have multiple DAGs, and you can basically say, I want to have 5 different DAGs. This is a performance thing, depending on how many sensors you're going to have running. And that basically you say, this is the maximum amount of sensing that one shard is going to do. This is the amount of shards that you want to do. And this is the enabled sensors. So what that means is Airflow, when it runs the sensors, it will first check is smart sensor activated, and only if it's true. Like if it's false, everything's the same as Airflow 1. If it's true, it will check, okay, the sensor that I'm using right now, the class name, is this class name in this comma-separated list of enabled sensors? And only if the sensor class name is found here, it will actually use the smart sensor. If it's not found here, everything just stays the same. If you set these k-walks if you set this k-walk to true, the DAG, the relevant DAG, is automatically added to your DAGs. So you don't have to do anything in your DAGs folder. And I just want to show you 2 things. The first one, I'll just quickly show you the DAG itself, and then I'll show you one example with the named Hive partition sensor. What you need to do if you want to make a sensor a smart sensor. So here we are. Oh, that's the wrong one. So this is essentially where the whole smart sensor DAGs are defined. And if you're interested in how it's implemented, this is the implementation. And this is also where this is where the smart sensor operator gets instantiated. And and you see the smart sensor operator itself is a child of the base operator. It will be initialized like the base operator. It has an execute method like the base operator, but like any operator. But the execute method is here essentially just a permanent loop, as you can see here. It's while true, just continuously checks the metadata database. Is there something I need to sense? If there is something I need to sense, poke it. So it instantiates the other operator, gives it the variables and the context, then pokes, and then checks if it was successful or not. And if it was successful, set the other task to true or false. And let's get that out. And I had and then let's take a look at this hive partition operator. So this is a child of the base sensor operator. And as I said, you also here as well, you're going to have an init method. And what you're also going to have is these poke context fields, much like the template fields. You need to set this in your class if you want to use the smart sensor feature. And what you set here is the arguments that essentially you get in your when you instantiate the class. Because what the smart sensor does is it looks for these fields, and when your task gets instantiated, it runs the init function and it supplies the arguments. So you supply the arguments, then you have an instance of this. And then what it does is, if it's a smart sensor, then it will try to fetch the attributes of these fields and add them to and basically get them and store them in the metadata database. Then it will delete the instance of this operator. Then at a later point, when the smart sensor itself runs and sees, okay, I have this operator that runs, it will reinstantiate the operator, and then it will give these arguments that it previously got from the previous instance again as arguments to the init function. So it will initialize a new class with the same arguments that previously it fetched. So this is why you need to supply, so basically set this field. And also you must basically have these two lines of code. So for each attribute, you have to store with the same naming. So the name of the argument, the keyword argument, has to be the same as the name of the attribute that you store it as, which has to be the same as what you give it here in the poke context field. And then this information will be supplied during the smart sensing. That's the first thing you need to be very aware of. And the second thing you need to be very aware of is that it will use the poke method. If you have a sensor where you override the execute method, it is not going to work because it completely ignores the execute method. It will only use the poke method to check, to sense, essentially. And as you can see, this example, it has been implemented. But if you want to use other sensors as a smart sensor, this is what you need to do. Yes. Okay. Any questions on this? Was this too detailed? Was this the right level of detail? Should I go?
I would say maybe a little too detailed.
A bit too detailed.
Yeah.
Perfect. Thank you. And then let's go to the next topic. Provider packages. So, as I featured earlier, I think provider packages are super cool. And Airflow was split into a core distribution and many provider packages, as I mentioned earlier, 60 of which are essentially community maintained. And you can also make any of your Python packages into a provider package. And this is nice because you have much less of a dependency mess in Airflow. Because you can, in your Airflow installation, now really only install those provider packages that you really need. And of course, you can build your own provider packages that you might use in your organization. Of course, you can also use the custom connection types feature that is basically a feature within the provider packages feature. This is something I will separately discuss in the next step after discussing the provider packages, which I think is also a very cool feature. Yep, so this is basically what it is and why it is, and how, I put down the bullets here. There's also some details in this link. It's not yet in the current docs, but the docs will be updated with the next release, and in this link you can already see the up-to-date version. And what you essentially have to do is create an entry point in your Python package, and then Airflow basically does all the rest for you. And I will show you an example of what this looks like in practice. And I think it's going to be a little less detailed than the sensors, at least I hope. Yeah, so this is basically what you can see here. So what you need to have your own provider package is you need to have a Python package. So in order to be a provider package, it already needs to be a Python package. So something you can install with pip. In this case, we have that in the Eva package. And you need to do three things. The first thing you need to do is in your setup config, you need to have these three lines. And really, all that is telling Airflow that there is a callable here in this directory of your package that it can import, and it will return a dictionary with some information. And this dictionary might look like this. And it's just some information on your provider package. If you have custom hooks, you can add the hook names here. If you have custom operators, you can add the operators here. You don't need to memorize this. This is in the docs as well. But this is all you need to do to create a provider package. Literally, this is it. And of course, if you want to have a list of hook names, you're going to have to create them. This is an example how I create them on the fly. But instead of that, you can also just have a text hook here. That might look like this. Something like that. And then it will just import these hooks and can then be used by the Airflow installation. And all you need to do is have Airflow installed and have this package separately installed in the same environment. And you don't need to do anything else except having this setup config in your own package and having this callable. As I said, in the link in the slides, we'll also provide you with a how-to guide of how to do this. And there are, as I said, two different classes, I would say, of provider packages. They work the same way, but they are differently maintained. So they are the community maintained packages and the custom provider packages. And now let's take a look at the community maintained packages. They are also in the Airflow repository, but they are their own Python package. That's, I think, important to distinguish. So you're going to have, it's in the Airflow subdirectory, then there's the providers subdirectory. And let's take, so you see all the providers that are community maintained are these subfolders. And they put everything they could into a provider package. And let's take an easy example. Postgres is, I think, an easy example. So in these provider packages, you usually would see operators and hooks. And then there's a in the community contributed ones, you have a provider YAML file, which contains the information in a YAML format that if you have a custom provider package that you do yourself, you have to supply in this callable. It's the same information. It's a name, some description, and the list of operators and your list of hooks. And if you want to use the custom connection types feature, the hook class names information. And then the operators and the hooks are in this provider package. And any dependency that these hooks and operators need are also going to be defined in this level. So you see, this is the operator without let's going through it. I mean, I already went through this, but yeah, this is how it works. So most there are still a couple of core operators that Airflow ships with out of the bag, but most operators that Airflow 1 had are now moved into these provider packages. So if you want to see the code of the individual hooks, usually you're going to look at the provider packages. So this is how they work in terms of community contributed provider packages. If you use them in your Airflow code, it's just instead of from Airflow operators Postgres operator import Postgres operator, you're going to have from Airflow providers Postgres operators import Postgres. So you basically put these providers in between, but otherwise it works the same as before in terms of how you load the operators or hooks for that matter. Any questions on community provided custom operators? Sorry, providers. If not, then I might also show you what a custom provider might look like. Well, I already did, sort of. So here, what you need to do, as I said, to have the setup config and then have this dictionary, and this dictionary is in the same format as in this YAML file that you saw here, and basically contains the information on your operators, and then anyone can just install it with pip and use it. So I guess that's also everything that I would have to say in terms of custom providers. Any questions on that?
How likely is it that we will ever have a custom provider? I don't know. Feels like something, or at least I never had the feeling I needed it, but maybe
Right. So this depends on how you like what you use, like how you use Airflow in your organization. Say you are an organization that has different people who use Airflow, and you have a central data engineering department that wants to provide operators to different people in your organization that then use these operators in their DAGs. That's, I think, a good use case for custom providers, because then you can just build a Python package that the other people can then use, where they can import these packages. This is also what you have to use if you want to use the custom connections feature. So the custom connection types, which I think is a very cool feature, is a feature that is part of the providers by the way that it is implemented. So when you use these, it's kind of a given that you have to do it. And in particular, if there's something that you want to open source, then I think it makes a lot of sense to offer it as a provider package, because then people can just install it with pip and use it in their code without any other steps in between. It's very user-friendly in that sense, which is also why I turned the EVA library into a custom provider package. And yeah, that's basically that's the use case that I see. Any follow-on on that or anything else? Then I will go into the custom connections. So again, what, why, how? I had already teased you earlier that the connection UI is now much more flexible. So you can rename the labels, and you can also hide labels or add labels depending on your need. And if we think about why that is, I just added a recall here. You have the operators. In the operators, you might use hooks, which are supposed to contain logic and connecting to external data sources. So, for example, a Postgres hook is supposed to talk with the Postgres database, and then you can use it in different operators or independent of operators, or call it in a function where you use your Python operator or something like that. And then there's the connections that save the credentials in the metadata database, ideally encrypted. And the issue was you might have different hooks might need different connection information. And this is made flexible with the custom connection types. And yeah, this is basically why this was implemented. And now I will show you how this is implemented. So it needs to the custom hook. So you need to have a custom hook to have a custom connection type. These hooks need two attributes that I'll show you, and it can have two methods that I will also show you. And this is what makes them a custom connection. And when you have these custom connections, you also need to add them. So in your provider package, you tell them, this is my custom hooks that contain custom connection types. And then in the hooks themselves, this is what it looks like. So in this is an example. These are three hooks that use it. For example, the Snowflake one. And what you really need is these two fields, because it will use the con type as the value that Airflow stores in the metadata database as to what connection type is the custom connection type. And the hook name is what is going to be shown in the UI to your user. So you need to have these two things to make a custom connection type. Technically, that's all you need. Obviously, if you use custom connection types, you also want to use some of the features. And to use the features, you use these two methods. And these should be static methods, could be class methods as well, but the Airflow does not instantiate your hook to access these methods. So I recommend using static method. And with the field behavior, you basically say, okay, there are fields in the standard connection that I don't want to show. Snowflake doesn't have a port, and I don't want to have an extra field. Also, the existing ones, I want to relabel. Right? I don't want to be called login, I want to be called user. And I want to use the host field to get the account. Right? This is fairly straightforward. You can just relabel it. If you need more than that, you have this other function, which is get connection form widgets. And here you can add custom widgets. And you can do this again by returning a dictionary, which just contains the fields. So this is the name of the field. It has to have this naming convention. So extra double underscore, then your connection type name, double underscore, and then the name of the field. Can have this is the field in the UI, and then you can tell it what widget to take. Any Flask widget works here. So integer widgets or password widgets or that kind of stuff. And under the hood, when you save stuff here, it will be saved in the extra. So in the metadata database, it will override the extra with a dictionary containing the values for these fields. That's why you should always hide the extra if you have some connection, like custom connection fields. Arguably, you don't need the extra anymore if you have this, because anything you would do in the extra before, you can now do in these kinds of fields. And just to give you an example, in the SSH connection type, I added the text area widget so there's more space to enter a private key, for example. And because the extra is encrypted, just like the password in the metadata database, it's fine to store passwords and credentials in there as well. So this is how you do it. Let me show you what it looks like. So here you have the standard connection form, how it used to look like. And then if I go to the SSH connection, you see it renamed. So here I have the renaming. And then here I have the text field widget, where I can also paste some information. And